what we are given is that 8 kilogram body is moved 0.2 meter to the right of equilibrium position and released from rest at t equal to 0. So you are given the mass of the body, which is 8 kilogram, and you are given initial condition that at t equal to 0, uh, x is equal to zero point 0.2 meter, and velocity is given, which is 0 meter per second. Uh, Determine the displacement at t equal to 2 second. So you need to find out displacement at t equal to 2 second is unknown. So this is what we want to calculate here. The viscous damping coefficient is 20 and the spring stiffness is 32. So you are also given C, which is 20 Newton second per meter, and you are given K, which is 32 Newton per meter. Okay, so to solve this problem, to find out this X here, the first thing that we need to know is the type of vibration. So it can either be under damped system or over damped system or critically damped system. We don't know this, so we can calculate this by just using the equation for zeta. So zeta is equal to c divided by 2m omega n. We can calculate omega n here, which is k divided by m under the root, which is k is given, m is given, so we can calculate uh, omega n, which become 2 radian per second. Okay, so from here we can calculate zeta. So this will become 22 times m, which is 8, and then times omega n, which is 2. So this become 0.625, and there is no units of zeta, so this means that zeta is less than 1. So we can see that zeta is less than 1, so this means that this is an under damped system. Okay, now for under damped system, we know that the solution of the system is x equal to c e power minus zeta omega nt sine omega dt plus psi. So this is the solution for a dynamic system when we have an under damped system. So in this equation, we can use this equation to calculate x, which is unknown, and we want to find it out for t equal to 2 second. But now the issue is that although we know the zeta, which is 0.625, we know omega n, and we can put the value of time, which is 2 second. But we need to calculate now omega d, and we also need to know c and this psi here. So to calculate omega d, we know the equation of omega d, which is omega n and 1 minus zeta square. So we know omega n and we know zeta, so we can calculate omega d, which become equal to 1.561 radian per second. Okay, so we can put the values of unknowns in equation, and we can see that how it will look like. So it become minus 1.25 t, and then it becomes sine omega d is 1.561 t plus psi here, and this 1.25 is just the multiplication of this zeta and omega n. Okay, now this equation, in this equation, now we need to know the value of c and psi. So to calculate c and psi, we will be just using the initial condition, which are this condition here. So to use these condition, we need to calculate x dot, which is the velocity. So that is, we will differentiate this equation with respect to time. So obviously this equation consisting of two terms of time. So we will just need to use the product rule for differentiation. So this will become minus 1.25 e power minus 125 t, and then it will become c, and sine 1.561 t plus psi, and then it become 1.561 c e power minus 1.25 t, and it become cos, so 1.561 t plus psi. So we have the equation for displacement and velocity. So now we can put the values of the initial condition, that is at t equal to 0, x is equal to 0.2 meter. So if we have, this is equation A, and we call this equation B. So if we put the initial condition in equation A, so what we will get is 0.2, and on the right hand side what we have is e power minus 1.25 t, so this will become 1, and obviously this term will disappear, so you will get 0.2 equal c sine psi. So this is the one equation, and then equation B will become equal to, because the velocity is 0 for t equal to 0, so it will become minus 1.25 c, and then sine psi plus 1.561 c cos pi psi. So we get these two equations here. Now from you can call this equation C, and you can call this equation D. Now equation D is giving us so from equation D what you can write is 1.25 c sine psi equal to 1.561 c cos psi, and from here we can calculate that sine psi divided by cos psi equal to 1.561 divided by 1.25, and which will become tangent psi become equal to 1.561 divided by 1.25. So from here we will be able to calculate psi, which is 0.896, and then if we have psi, then from equation C we can calculate C here, which will become equal to 0.256. Okay, now if we know this C and we know psi, so we can put this back in our equation for the displacement, which is equation A. So equation A will become equal to x, which is c, so c is 0.256, and e power minus 1.25 t, and it will become 1.561 t plus 0.896. So we just put the value of c, which is this 0.256, and the value of psi, which is 0.896. So now if you just put t equal to 2 second here, you will get the value of the x, which is minus 0.01616 meter. So this is the value of the x, or again you can say that it's become 16 millimeter, and the negative sign is just showing us the direction, so that it is toward the right or to the left. So this means that it is toward the left side.